papers. Dr. M. Nijamuddin Saab is Associate Professor at Jamia Millia Islamia, New Delhi. He has completed PhD, VLSI and Nanoelectronics, MTech, Nanotechnology, and Bachelor of Engineering, Electronics and Communication, and all three from Jamia Millia Islamia, New Delhi, India. Dr. Nizam is working as Associate Professor in Department of Electronics and Communication Engineering, Jamia Millia Islamia, New Delhi since 28th March 2017. He is Assistant Nodal Officer, National Academic Advisor Depository, NAD Cell, Jamia Millia Islamia from 16 Feb 2018. Earlier, he has worked at several reputed places, including Assistant Professor at Senior Scale in Electronics and Communication Engineering Department, Mewat Engineering College, Haryana. Dr. M. Nijamuddin Saab has got several best research paper awards in reputed international conferences. He has filed 2 patents titled as Electromechanical System and Method for Information Compression, and System and Method for Low Cost Microscopy. He has published more than 50 research papers, book chapters, including several SCI papers. He has guided 16 MTech theses. He has also worked as Training and Placement Officer at Mewat Engineering College from 2012 to 2016. Further, he has organized several conferences, seminars over here as well as in Jamia. His field of interest include VLSI, very large scale integration, devices and nanoelectronic circuits and embedded system. So this was a bit brief about our ex-colleague, Dr. M. Nijamuddin Saab, who is now Associate Professor with Jamia Millia Islamia. So now I think we should move forward for the paper presentation, and I just tell my participants that Dr. Mohammad Junaid is also here, and he will be calling upon various papers, and as a session judge, Dr. M. Nijamuddin Saab, Mohammad Nijamuddin Saab will be assessing the quality of the papers, and he'll be giving his final comments to Dr. Mohammad Junaid Saab, and accordingly we will be moving forward in this session. I think this is all from my side. Now it is over to Dr. Mohammad Nijamuddin Saab.
Thank you, Dr. Shaheen Khan. First of all, I would like to thank the Honorable Director of Mewat Engineering College. I'm really happy that he has just told this is the second conference. I was expecting that this is the first conference being organized by MSc, but in a short span of time, okay, he has organized 2 conferences. I personally congratulate him. And also, you know, where people will know very well, I'm physically in Jamia, but my heart beats for Mewat Engineering College as well. Whatever I am today, Mewat Engineering College has a vital role in it. Today, being a session chair, first of all, I would like to tell my young technocrats who are going to present their papers that they should focus on their work only. This is my personal request that please do not waste your precious time while you will present your papers. So you have to focus on the work, on the results. Okay, need not to explain the basics of the field. And while you are delivering a lecture, please, I would like to request the audience, please do not disturb the presenters in between if he is not feeling comfortable. Because if you have rejected almost 50% papers, because there are more than 100 papers were received and you have accepted 53, it means quality publication will be there. Quality publishers or quality presentation will be in this conference. So it is my request to the people who are going to ask questions, please try to make a question answer session at the end of the presentation. So now I request Dr. Junaid to start the presentation. And I also request Dr. Shaheen Khan, please share the list of papers with me.
Dak Sahab, I have already sent you list just now. I think it is on your account.
Okay. Let me check, please. Thank you. Dr. Junaid, you just start, please.
Okay, thank you,
Dr.
sir.
Junaid, you can
Yes.
start calling the presenters, and Dr. Nizamuddin may have a look, and the list also must be with Dr. Nizamuddin. However, if anything need to be clarified, so you can talk to Dr. Nizamuddin. Dr. Junaid, you may talk to Dr. Nizamuddin. However, there must not be an issue. Let us start with first presentation, and if there are challenges, we'll sort it out. So, Dr. Junaid, you can announce, please.
Okay, sir. I call to paper ID 2836 maximum power generation from photovoltaic system. The authors of this article, Mohit Sanger, Muzakir Khan, Ashok Kumar, and Mohammad Junaid Khan. The presenter of this article, Mohit Sanger. Please continue for the further proceed.
Thank you, sir. Thank you. So good afternoon. Good afternoon for all, sir. My name is Mohit Sanger, and thank you for accepting my research paper. So further studies. So we have project is maximum power point generation for photovoltaic system. We are tracking the maximum power using PV system. Basically, PV system is a solar device which is used to convert,
Please share your PPTs. Please share your PPTs.
I don't know, sir, how to share. It's first time to sir on Zoom. That it is difficult. Can you
I
explain,
think we
sir?
will invite this speaker later on. We should invite someone else because presentation is very important, right? Dr. Junaid,
Okay.
please invite someone else.
Okay, thank you, sir. The paper ID 2837, the paper title is Simulation Model of Boost Converter in Various Sampling Time. The author of this article, Samina Parveen, Mohammad Sawan, and Mohammad Junaid. Department of Electrical and Electronics Engineering, Mewat Engineering College. The presenter of this article, Mohammad Sawan. Please.
Hello, good afternoon, sir, and Assalamu alaikum, everyone. I'm Mohammad Shahban, and my topic is. Uh, Please allow me to share my screen. I'm audible to
Share
you.
your screen. I think it is permitted.
Yes, sir.
I think you're allowed to share your screen.
Okay, sir. Thank you, sir. Are you visible, sir?
You are sharing your screen, and this is visible.
Let me start. So my topic is simulation model of boost converter in various sampling time. And my presentation overview is first we introduce the boost converter in which we study the block and circuit diagram and its component and diagram and its component and working application. Then we study the simulation model in which we study why simulation are used, simulation model of boost converter, and then we see the graph and results, and then we reach at the conclusion. My first slide is introduction to the boost converter. A boost converter is one of the simplest type of switch mode converter, as the name suggested, it takes an input voltage and boosts and increase it. This is the actual image, and this is the circuit diagram. It has the component voltage source, inductor, IGBT switch, diode, and capacitor. And next slide is block diagram. This is the block diagram. In this, the voltage source provides the input DC voltage to the switch control and also to the magnetic field storage element. The block, which contains switch control, directs the action of switching element, whereas the output rectifier and filter deliver an acceptable DC voltage to the output. My next slide is working a boost converter. The function of boost converter has two modes, mode 1 and mode 2. Mode 1 begin when IGBT is switched on at time 0. The input current rises and flows through the inductor L and IGBT. The next mode is mode 2, begin with IGBT is switched off at time t1. The input current now flows through load R and diode. The inductor current falls until the next cycle. The energy stored in the inductor flows through the load. And then application of boost converter is the DC converter are widely used for the motor traction motor control in the electric automobile, trolley cars, marine hoist, forklift truck, and mine haulers. And then they can be used in the regenerative banking of DC motor to return energy back into the supply. This attribute results in energy saving for transportation system with frequent steps. And third application is the DC converter are used in the DC voltage regulator and also are used with an inductor in conjugation to generate a DC current source, especially for the current source inverter. Simulation modeling is the process of creating and analyzing a digital prototype of a physical model to predict its performance in the real world. Below, we can see the circuit diagram for MATLAB simulation of boost converter. The purpose of this circuit is to measure output voltage, current, and power waveform. In this, we perform three experiments at 50 microsecond, 25 microsecond, and 25 microsecond and 5 microsecond sampling time. And the result and graph are this. This is the input voltage with sampling time 50 microsecond, and this is the output voltage with 50 microsecond. And this is the input current with sampling time 50 microsecond, and this is the 50 in output current with sampling time 50 microsecond. And next we see the output input power with sampling time 50 microsecond, and this is output power with sampling time 50 microsecond. And next we perform the at 25 microsecond, then we get the result and graph like that. This is the input voltage, which is 100 volt with sampling time 25 microsecond. This is the output voltage, which is 120 volt at mm, at 25 sampling time 25 microsecond. And next slide is on my input current and output current. This is the graph of input current with sampling time 25 microsecond, and this is the output current with sampling time 25 microsecond. Next slide. This is out input current, which is 1000 watt at sampling time 25 microsecond, and this is the output power with sampling time 25 microsecond. Next, we perform the boost converter at the sampling time 25 at the sampling time 5 microseconds. This is the input voltage at sampling time 5 microseconds. This is the output voltage with sampling time 5 microseconds. And next we can see the current. This is the input current with sampling time 25 microseconds, and this is the graph of the output current with sampling time 5 microseconds. And this is the input power of the sampling time 5 microseconds, and this is the output power of sampling time at 5 microseconds. And conclusion of my experiment is all of the specifications stated previously have been met by this boost converter design MATLAB simulation using calculated parameter where the performed and corresponding waveform were obtained. The power efficiency of the circuit is 98.8%. The load resistance is 15 ohm. It is observed by varying duty cycle. It is observed by varying duty cycle. Output voltage also changes. And when we change the sampling time, the output voltage also change. Using sampling time 25 microseconds provide more accurate and stable result as compared to the sampling time 50 microsecond and 5 microsecond. So this is my presentation. So thank you to everyone.
Any question?
Any questions, sir?
Any question from audience? Anyway, what's the reason for 98.8% power efficiency? Can you explain?
Sir, this is 9 हम पहले से एज्यूम करा था कि हम इस एफिशिएंसीज के 100% देंगे, बट एज अ रिजल्ट
Is it practically possible?
no,
This is a
sir,
simulation work.
this is simulation work.
Yeah.
Yeah, it is not practically possible.
So what will be the practical one? If suppose you are going to fabricate or design this boost converter, so what is your expectation regarding power efficiency?
Regarding of efficiency, like just 70% or 60% which we observe, because the boost converter is the highly efficiency. So therefore it is used in the many industrial places because they are highly efficiency device which is converted DC directly.
Okay, I have few suggestions. While you will go for presentation next time, so I will advise you that you should add the page number also. Okay.
Okay, sir.
Page number in slides. Apart from it, you was missing the references. You have used several type of diagrams. I think these diagrams are from some reputed papers. Okay, so
Yes,
please
sir.
add the name of their references. Okay, number.
Okay.
Right.
Okay, sir.
Okay. Anyone else? Is there any other question? Yes, Dr. Junaid.
Yes, sir.
Let's invite another one.
Okay. Thank you, मोहम्मद शाबान. Please,
Yes, sir.
आप स्क्रीन से आउट हो जाइए अब.
एक मिनट सर,
Screen. Yes. Again, call to Moish Sanger. Please share your PPTs and present your presentation.
Okay, sir. Wait, sir. Wait, sir. I'm sharing my presentation, sir. Is it visible, sir?
No.
I think I'm facing something problem, sir. I'm clicking on it again and again, but it's not visible, sir.
शेयर कर पा रहे हैं आप अपनी तरफ से?
No, sir.
शेयर का ऑप्शन दिखाई दे रहा है?
सर मैं ट्राई कर रहा हूँ, बट सर जैसे ही क्लिक करता हूँ सर वो वापस इस पे ही आ जाता है.
No problem. We will give one more chance. Now, let's invite someone else.
Okay. Next presenter, I call to paper ID 2108. The title of paper: FinFET based digital circuits at diverse nano channel length and exploration. The authors of this article: Adil Zaidi, Mujib Khan, Muhammad Saib, Azim Zaidi, Shaheen Khan. The presenter of this, Muhammad Saib, please present your paper presentation. Please share your PPTs.
Good afternoon, sir. I'm Mujib Khan from EC department. Sir, I will present this paper on the behalf of Sahib. Sir, please allow my PPT to share.
You can share, you are allowed.
All are allowed. I need not to ask. Okay. Once you have been invited for presentation, so you are allowed for the things.
Please let me know if there is my voice and my screen is visible.
Okay. Double click at FinFET.
Sir, my screen and my voice is clear there.
Yes. Your screen is visible. Okay.
Thank you, sir.
But your presentation. Please start your presentation.
Thank you, sir. Thank you, sir. So today I'm going to present a review work based on FinFET-based digital circuit at diverse channel length and exploration. The prime objective behind this work is to explore new devices to replace ordinary or bulk CMOS. Because of rising of short channel effects and threshold roll-off and low packaging density, we need to scale down further these devices, and there are some issues arising in the subnode of 10 nanometer. So we try to replace bulk CMOS to the another devices. Like architecture is proposed that is called FinFET technology. In this architecture, the gate is in vertical form, and as we know that in bulk CMOS, the gate is lying under beneath the gate, and the channel is lying under beneath the gate in the horizontal form. So in this paper, we try to study and simulation of various digital circuits at various channel length at nominal power supplies. So we can see that there is a architecture of planar MOSFET is shown in the figure, and
There.
yes, but sir,
भाई screen तो share हो ही नहीं रही है इनकी. Please share your screen. Start your presentation, बेटा. आपको share तो हो नहीं है.
उसमें क्लिक करो, उसको क्लिक
Your
करो, डबल
screen is
क्लिक करो,
visible,
open
but
करो.
presentation is not there.
sir, I am presenting my screen, sir. I think there is some technical issue. Are you able to
very
see
good.
my screen right now?
Yes, nice.
Thank you. So as we can see, a planar MOSFET and 3D MOSFET is shown in the figure.
No, please
And
stop. First, share your screen.
Sir, I'm sharing my screen, but
Your screen is very much visible, no problem. But start your presentation. Double click at FinFET. What are you doing?
sir, I'm presenting my screen, but at when I try to play the PPT, I think there is some technical problem. You are not showing.
There is
you
no
are not
technical
watching
problem.
it.
Just click on FinFET. You tried just now, na? You try again.
Yes, sir.
Click at
Okay.
FinFET.
It is, sir.
You should make practice before presentation, okay?
Okay, sir. Okay, sir.
And it is a part of research. How to present your work is also very nice, very good. Now,
So now my screen is visible.
your screen is presentation is also visible. Your screen was earlier visible as well. Okay, now the full screen.
So whenever I'm clicking on the full screen,
Shabash, nice. Yes, now start.
now it is visible, sir.
Yes, clear.
Okay, thanks. In the figure, we can see a planar MOSFET in which the channel is lying under the gate. And in the kind of FinFET devices, we are having a vertical channel in the under the gate. So there are some disadvantages of planar devices, like we are having a short channel effect and the threshold voltage roll off. And we are having another disadvantage of planar MOSFET is that we are having a poor gate control abilities. That means the gate is not able to switch off the channel fully, because of there is always a leakage in the channel. And there are some other issues like high leakage current and DIBL induced barrier. And whereas on the other side, FinFET are having a better gate control abilities, and FinFET show a very low leakage current and high. Because of low leakage current, we can further reduce the size of gate length, so we can fabricate more number of transistor in a small area. That is called the high packaging density. And in the case of FinFET, we are having a low power consuming devices, so which causes high scaling densities. Similarly, BJT, we can have a different kind of modes in the FinFET devices. We can use FinFET in a short gate mode and low power mode, and we can also use this devices in independent gate mode. In short gate mode, both of gate are short circuited, and in the low power mode, we can connect the any gate to the low wires and any other gate to the other voltage level. But in the case of independent gate, we can use both the gate independently, and we can as we desire. Whereas the low power consumption and low leakage power is required, we can use this independent gate. In this section, we have explored the XOR gate using this FinFET technology, and we in the case of FinFET technology, we can see that PDP is very low. It's almost near the zero. And in the case of CMOS technology, we can see that the PDP is very high. So this using of FinFET technology show a significant reduction in the PDP by using this circuit. Furthermore, we have calculated and simulated the other logic gates based on FinFET technology at diverse channel length. We reduce the channel length from 22 nanometer to 14 nanometer in the gate length. FinFET-based NAND gate is presented here. We replace all the CMOS using in the previous technology with the FinFET NAND gate, with the FinFET devices in the NAND gate. And we can see the parameters of FinFET NAND gate in the figure in the graphical manner. So we can generally see that the average power and maximum power is significantly reduced in the case of NAND gate, FinFET-based NAND gate. When we go further down in the less channel length. At 22 nanometer, we can see that NAND gate is showing a more power consumption, but in the 14 nanometer, we can say that it is consuming less power in the both case. But the major disadvantage of this kind of circuit that we are having a certain delay in the kind of circuits. Furthermore, we have also simulated NOR gate with the help of this FinFET gate devices, FinFET-based devices, and we can here we can also see that average power and maximum power is also reduced significantly. And delay in the case of NOR gate is also high, which is also a disadvantage of FinFET devices when we compare to shorter channel length in same technology. Here are some FinFET-based combinational circuit also presented. We can say that we have presented 2-in-1 mux by using of FinFET technology. Hello. Hello. In this section, we have presented 2-in-1 mux with the help of FinFET devices, and we have seen the power consumption with the help of 2-in-1 CMOS mux, and we can conclude that from the figure that the FinFET and CMOS comparison, the power consumption in the case of FinFET is very low. It's almost negligible in the case of FinFET as when we compare to bulk CMOS. There is also another circuit which is a full adder. FinFET based full adder is also presented and simulated all the study and investigation. We can say that delay in this circuit is also reduced when we compare to CMOS full adder, and leakage power reduction is also there. We can see that from the table I demonstrated that, and there are some sequential circuits also presented in this work, and we simulated schematic. We have shown the schematic of latch tight gate in 32 nanometer technology and latch independent gate. Actually, in this section, we are comparing both of the modes in the FinFET technology. In this circuit is made of the latch tight gate, and this is the independent gate, as we mentioned earlier. So we can see that in the case of tight gate and independent gate, the active power consumption is very low in the case of independent gate. In the case of that, both of gate are working independently, and in tight gate, both of gate is working in the tight manner. We can see that average power is almost equal, but there is somehow a reduction in some cases, also in average delay. Similarly, a master slab flip-flop is also presented in this paper with the using of CMOS and FinFET technology, and we can see delay graph with the help of this graph diagram that FinFET is showing less delay in compared to CMOS technology. And there is also a shift register is presented and simulated with the help of FinFET shift register, FinFET technology, and we can see that leakage current and leakage power is reduced significantly, and we can see that in the graph. Conclusion: we can conclude from all the previous study and exploration that FinFETs are better in the leakage reduction and very low power consuming devices with compared to CMOS. So we can totally replace the CMOS technology with the FinFET technology, and in 2015 Samsung used first 14 nanometer process Exynos 7420. And however, there are some limits of FinFET technology. We can further we cannot scale down, as it is predicted that the limit of FinFET technology will be around 5 nanometer to 3 nanometer. But for the current stage, it emerged as the best possible technology to fabricate in the microprocessor and other devices. Thank you, sir. Thank you, sir. If there is any question? Hello, sir.
Is there any question?
Yes, sir.
Yes, welcome.
My question is why you use all not function gate like NAND gate, NOR gate, XOR gate? What happens when we use AND or OR gate? This is possible or not?
Actually, we can use any gate with the help of FinFET technology because it is just a devices, and the demonstration of universal gate is shown for the convenient that because we can realize any of logic function with the help of these both universal gates NOR and NAND. So we can further realize the expression of AND gate and OR gate with the help of NOR and NAND gate. I think it's clear.
What's the reason for better gate controllability in case of FinFET as compared with CMOS?
Sir, unique 3D architecture show better gate controlling ability in the case of FinFET, and we can further uh, increase dielectric constant, dielectric material, and the width of the dielectric layer in the channel.
So what will be the drawback?
Drawbacks are that we are getting when we going further in the scaling of FinFET technology, then we are showing some delays in increasing.
Is it more complex to fabricate FinFET based devices or not?
No, sir. It is more actually. It is more simple to fabricate the FinFET technology as compared to CMOS technology.
Okay. So same mistake you have done here. You have not mentioned the serial numbers, slide numbers, okay, and
Okay,
never use the references. Okay, these are the
okay,
things
sir.
which you have to keep in mind. Okay, thank
Okay,
you.
sir. Okay, sir.
Let's invite
Thank you,
someone
sir.
else, please.
Thank you, sir. I call to paper ID 230. The paper title is a study on integration of renewable energy sources. The author of this article, Sarfaraz. The presenter of this article also Sarfaraz. Please present your paper. Sarfaraz.
Yes, sir. Yes, sir. Sir, you got my screen?
Yes. Yes, share your presentation also.
Yeah, wait. Sir, you got my screen or not?
Yes.
And my presentation?
Yes. Start slideshow.
Please present your presentation, please.
Yes, I'll do.
Don't waste of time, please present.
You are on track. What's the problem?
Sir, I'm not finding.
Click add slideshow.
It's a slide, so.
Okay, go to slideshow, no problem. Go to slideshow.
I'm on, wait.
Bring your cursor to slideshow. At the top of your screen is you at the left side. Beta, you have to make practice because presentation, because this is part of your research also, okay? If you are unable to present the things which you have designed,
Sir.
You click at slideshow. Open your presentation again.
Can you got my screen, sir?
Open your presentation.
Hello?
Hello.
Hello?
Hi, yes.
Is my screen there?
Your screen is very much visible.
I'm
No
not listening.
problem.
Wait.
अरे भाई आप क्या बात कर रहे हैं?
Actually, sir, I'm not found the option.
नहीं
There is
नहीं
new share.
नहीं your screen is shared. We are visualizing your screen. You
Okay.
open your presentation first.
Okay.
हाँ,
You got it?
wait. Yes. Now click at slideshow. Or simply click F5. Okay. You just click F5. It will be start up again itself. Very good. Now start.
Sir, good afternoon, sir. My name is Rtreaet.
What is your
I am
paper
test student
ID?
from Rtreaet 230. 230.
Okay. Start.
Sir, good afternoon, sir. Everyone here. Sir, I'm presenting my paper on a study of integration on renewable energy and sources. As you know that renewable energy is termed used to refer the form of energy which is you can say non-consumable energy, means that are naturally obtained from environment and from sources that can be replaced naturally. These are the renewable energy are those sources which we got from the nature. These include solar energy, wind energy, geothermal energy, and hydro power and biomass. Here from some last decades, mechanical energy like coal, gas, oil, and other are in basic conditions, and because of this, there is a key development being developed on renewable energy, renewable energy assets. Because of these restricted accessibility of these mechanical fields, renewable energy assets are ending up increasing well known nowadays. There are likewise some other purpose behind their ubiquity, like their accessibility in immense sum. They are recyclable and they are eco accommodating and did not discharge any destructive gases. Additionally, give answer for worldwide temperature alteration issue. There are few uh, RERs, renewable energy risk assets, are available like breeze, sun powered, tidal, and hydro, and so forth. Among all these renewable assets,
Please
wind and sun.
stop. Do not introduce the things. Please, I have told you in the beginning that you have to present your work. Whatever you have done in research, that is required to be presented here. Need not to explain the introduction.
Okay, sir. In this here we have here I'm presenting the theory of photovoltaic across the how the uh, photovoltaic work, uh, mainly the sun solar power, how solar power works. uh, the solar energy. What is solar energy? Solar energy is the energy which we derived from the sunlight, and uh, uh, it converts this light energy into the electricity. Also, it converts heat energy into the electricity. uh, Light into heat energy. Okay, sir. Partial list of other solar applications. There are different solar applications like space heating, cooling through solar architecture, daylight, solar hot water, solar cooking and high temperature, etc. These are the solar energy. Solar technologies are broadly characterized as either passive or active solar, depending upon. We can characterize the solar power in two forms, basically passive solar and active solar, depending on the way captured and convert and distribution of solar energy. Here we have PV structure. Generally, PV structure of PVC simply contains total fixed different layers of material as given in figure below. In this glass, we protect what a solar PV have. I'm telling now. In this glass, it has glass which protect the cell from atmospheric condition. We can minimize the reflection losses up to 5% by using anti-reflecting coating. If you are using anti-reflecting coating, we can reduce the losses of solar PV. Uh, then we have contract grid, which will minimize traveling distance of photons, so that we can reach the solar conversion easily. Main component of PV systems is P and N, P type and N type, which are available in the form of the two layers, which I am describing down like this. This is the base structure of solar PV. Solar when the solar is solar cell, it will convert. It has N type and P type silicon, and here we have holes and electrons. Holes have positive charge and electrons have negative charge. When light falls on the solar cell, it convert electric energy into the light energy into the electric energy, and light energy into heat energy, vice versa, and so on. Uh, Here we have the problem which are facing while we have solar energy. Uh, as we know that the solar and the system use are not stable and varying in nature. We need to hybridize wind power generation and solar power generation with batteries bank, as there are some conditions when there is not any power supply by solar or wind devices. Batteries have to supply enough power requirement. In this case, the wind power is completely different from the conventional energy generation system like fossil fuel, hydroelectric, and nuclear fuel, etc. Uh, but this has also been noted that wind power is one of the most inexpensive power generation sources among renewable energy system. Uh, Photovoltaic are the generally known as photovoltaic component, commonly in language known as these cells, are completed to convert solar energy available from the sunlight to the rays of sun rays to the electric energy using PNP solar system. Here are the uh, result of the solar system which we are using these days. There are various analysis of various irradiation temperature and radiation variations from below figure 1 and 2. Here we have the two figures 1 and 2. We can easily observe effect of variation in solar radiation of the on the power voltage characteristics as figure 1. This one, we noted that solar radiation is having proportional nature, and with circuit current, this means that we increase in the solar radiation, there is a considerable increase in the short circuit current. Here we have the short circuit current when we are using solar power and solar, we can say solar panels. There are the short circuit current, which is which is mainly the important part of the solar panel, uh, solar panel. That is the current is mostly affected by solar radiation, as we note that the figure 2, this one, that this when solar radiation is raised to 700 to 1000 meter square, then this where the current value will rise from 5.7 ampere to 8.2 ampere, but this effect of our voltage observed to very less. And this has been observed that the increase in solar radiation power generation also increase. If we increase if the radiation of the solar sun is increased, then the current of the photovoltaic cell, means solar cell, you can say solar panel, is increased. This increase in power is mainly because of the increase in current. If it happened when if the intensity of the sunlight is increased, then it will then the current short circuit current is increased. This short circuit current is converted into the electric uh, voltage. With that, next one. In the figure 3, we saw below the result of varying temperature of the current and voltage characteristic of the photovoltaic cell is given in the figure. From the figure, we can observe that temperature variation will generally affect our voltage. As we increase in temperature, there is decrease in the voltage. Here we have in the solar system, if you increase the temperature, then the voltage of the system is decrease. Uh, as we increase the temperature, there is a decrease in the voltage, and current will remain voltage, but the current will remain constant for a period of constant period of time. If you increase the as a standard limit of the temperature, then it will not work as far as uh, the specification of solar panels. From figure 4 below, we have figure 4 here, that one. Next one is the effect of temperature for figure this one. Effect of variation of photo power and the voltage character इसमें है. Figure 5. This is 5 and this is 6. As we can clearly see in the figure 5 below, region having laser current than the unshaded module in partial shaded region. This one. These are the figure 5 and
Okay, continue. Hello. Hello. Hello.
I think Nizam Sahab, we can go
Hello.
for the next. Nizam Sahab, I
Okay,
think we
okay,
can
next.
go for the
Yes,
next one.
yes, yes. Yes,
Because
yes,
he has
yes,
already
yes.
taken a lot of time.
Yes, next.
Sarfaraz. Hello. Any
Dr. Dinesh,
question,
please invite another one.
Okay, thank you, sir.
Already he has used a lot of time.
I call to
Let's invite
paper
her.
ID.
Paper ID.
Okay, sir. Thank you. Paper ID 1481.
Okay.
The paper title is Relevance of HBOF Spray and Way to Coat. The authors of this article, Mohsin Khan, Wasim Akram, Azaz Khan, Mewat. The presenter of this article, Mohsin Khan, Wasim Akram, and Azaz Khan. Please continue for the presentation of this article.
Respected director, sir, chairpersons, a very good afternoon. Am I audible, sir?
Yes, you are very much audible.
Thank you so much, sir. I am Mohsin Khan, Assistant Professor, Mechanical Engineering Department, Mewat Engineering College. The topic of my research paper is relevance of HBOF spray and way to coat. In this research paper, we have reviewed the ongoing work of HBOF, where HBOF stands for High Velocity Oxy-Fuel. This is a type of spray coating in which the spray is performed at very high velocity, rate, and as its name suggests that HVOF. In this spray coating, the velocity is generated with the help of fuel. The fuel may be normally used, which may be alcohol based or other, which we are using in our motorbike or engines. The working end diagram will be shown in the slides. This is the abstract of my paper, which I have explained as now. This is the diagram which I was talking about. Actually, most of the things I have discussed in this introductory session. In addition, the metal material and ceramic nanostructures, powders, and many other powders are used in HPF technology. There is a diagram in the downside of the slide, which shows the process of HVOF spraying. This is the way that how HVOF works. You can see clearly that the fuel gases and oxygen are burned to get desired velocity and temperature. In the mid of this diagram, a powder and carrier gas is placed, which accelerates at high velocity. Further, the material powder converts into splats. Splats are the melted particles of the material we have used. These melted particles are then strike on the substrate which we want coating on which we want coating. Like in this diagram, the top right slide sorry, the rightmost is the substrate, and coating is developed on this substrate, which is due to this high velocity oxy-fuel process. This process is performed with the instrument known as spray gun. The diagram shows the spray gun very much clearly. There are some developments in last decades in which the flame temperature is reduced and particle velocity are increased. Like in this slide, the first generation HVOF consists of 1800 to 2000 degrees Celsius flame temperature and 240 to 500 meter per second particle velocity. And in second generation, it is of 1600 to 1850 degrees Celsius flame temperature. Likewise, the velocity will be 570 to 650, and in third generation, the flame temperature reduced to 950 to 850, and the particle velocity increased to 500 to 825. In this way, we can see that in the coming generations, the flame temperature is decreasing and particle velocity is increasing. We want the minimum temperature and maximum particle velocity, which will give our best results while we coating on any substrate. Next is our bonding mechanism. This is the most important factor in spray coating technology, because without bonding, no coating is possible, and high temperature helps to bond the splat particles with substrate. Some of the applications of spray coating are manufacturing components. We can improve the component service life, repair the existing parts, salvage mismatched components. If there is a mismatched component, then we can add some material on it. If some material, some component is machined at high level, then we can add some material by using spray coating. And this is also a small contribution in additive manufacturing of this coating. Now I would like to conclude my presentation. In HVF thermal spray coating, the review is presented from my side. Uh, and in last 2.5 decades, HVF spray technique have considerably modified and improved. This technique have been commercialized and very rapidly commercialized very rapidly due to its characteristics and results. Also, the powder technology plays a very crucial role in spray coating. Due to its high temperature and coating suits better for many applications as we have seen earlier. This technology, as I have told earlier, plays an important role in additive manufacturing also. Thank you so much. These are the references I have used. Any question?
Very good. Is there any question from audience? Anyway,
Thank you so much.
what will be the impact if we will reduce the size of powder to nanoscale?
If we reduce the size of powder to up to what level we can reduce, the size of powder converts into splats, as I have told, due to the temperature increased, and whatever the reduced size we are using, the coating will be much better as we reduce the size of nanoparticle, or we
Why?
reduce
Why? What's the reason?
however we reduce the because
No,
the particle get melted totally, and it may strike on the substrate, and it covers the whole surface fully.
Yes. What is the surface area will increase when we will reduce the size of material?
Sorry, sir, I am not getting the point.
Suppose we are going to reduce the size of a particle, then the surface to
Okay,
volume
okay.
ratio will increase or decrease?
Sir, it depends upon how much we are supplying the powder. As in
No.
our
I'm talking
spray
about
gun.
the particle size actually. If suppose we are going to reduce the size of
Sir,
a particle or a material, whatsoever it is, so
yes, sir.
of course the surface area will increase
Surface,
and the
it will
volume
cover
will
less
increase.
surface as compared to the yeah. It cover less surface as compared to the large particle size.
So what will be the advantages?
Advantages are that there are will be the less limitations or less impurities present in the small particle size. As the particle size is as much as small, the impurities or the जो कमियां होंगी वो minimize.
What are that limitations which will be reduced? बताइए आप क्या कमियां हैं वो? Like we are using
So like
nano coatings. Presently we are using using nano materials in coating, right? Paints. Okay.
Yes, sir.
So what are
Yes,
its advantages? Can you
yes,
tell
sir.
me?
Sir, it improves the life of the material on which we are applying the coating.
Okay, nice.
It also improves the
strength.
Thank you so much.
Strength will be increased or not?
Strength, many mechanical properties are changed and improved.
Very nice. Okay, thank you.
This coating is also used. Yeah, thank you.
Okay, let's invite another one.
Thank you, sir. I call to paper ID 2682. The paper title is CNN based eye center localization. Naseem Ahmed is the author of this article, EC Department, MEC. The presenter of this article, Naseem Ahmed. Please present your article.
Respected Director Sir, Chairpersons, and all of one presented here. Assalamu alaikum. A very good afternoon to all. Today, I am grateful to present my research, my paper on CNN-based eye center detection. I am sharing my screen. Please confirm, Nijamuddin sir. Is it visible?
Your screen is visible, but presentation is not visible.
Now?
Still not.
Hope it is visible now.
Share your screen. I think you are not sharing it.
I have shared, sir.
What's the problem then?
Okay. It may be some network issue. Actually, yeah. Yes, sir. I am running my PPT. Is it visible?
No.
मिस्टर मोहसिन प्लीज आपने जो शेयर कर रखा है उसको आप जो है हटा दीजिए. रिमूव योर शेयरिंग. मोहसिन, मिस्टर मोहसिन, प्लीज रिमूव योर शेयरिंग स्क्रीन. मिस्टर मोहसिन.
Yes, should I present, sir? Junaid, sir? Actually,
Wait, please.
ऐसे बैठ जाइए, मैं बैठा हूँ. डॉक्टर शाहीन, ये मौसम की स्क्रीन को आप वो कर दीजिए. या यू मेक मी होस्ट, आई विल मेक द चेंजेस. डॉक्टर शाहीन. Dr. Shahin, are you able to hear me?
Yes, sir. I try to remove
Sir,
this.
we are trying to remove, but there is a problem with my system also. I'm just trying.
No, simply you give me the host. I will make the changes. Make me host.
So I have disconnected all the things.
Okay.
Maybe it is a server problem, sir.
नहीं, अगर शाहिद साहब, if you will make me host, I'll make the changes. So we'll disconnect. Naseem, are you able to share your screen? Naseem?
Sir, I have made you host. Now you please control.
Yes. Yeah, thank you very much.
Sir, Director sir, now you are the host.
Yes, I am the host. I'll make the changes. So now, who is the participant who would like to make a presentation? Naseem?
Naseem sir want to make presentation, sir. Mohsin's
So
screen is
you
coming.
can share it now. Yes, you can share it now.
Naseem sir, go ahead.
Naseem, please share.
Ah.
Under process.
Past exam.
नसीम शेयर कर पा रहे हो तुम स्क्रीन? नसीम, नसीम तुम शेयर कर पा रहे हो स्क्रीन को? नसीम तुमको हमारी आवाज आ रही है? Dr. Junaid, can you invite somebody else? Maybe Mr. Naseem can present after this presentation.
Yes, sir.
Please.
I call to Mr.
Aziz.
Abdul Azim. The paper ID is
Abdul Aziz.
2824. The paper title is Analysis and Testing of Multifunctional Relay using IE C61850 protocol. The author of this article, Abdul Azim Mazi Jamil Bhattacharya Sanat, or the presenter of this article, Abdul Azim. Please present your article.
Abdul Aziz, are you present?
Sir, he is present.
Call next. अब्दुल अजीम तो है यहाँ पर. अब्दुल अजीम या अब्दुल अजीज है वो?
Azim, sir.
Mr. Abdul Azim, you are present. Can you unmute yourself? अब्दुल अजीम रिस्पॉन्ड नहीं कर रहे हैं, बोल भी नहीं रहे हैं, तो यू कैन इनवाइट समबडी एल्स. कोई और कोई बुलाओ फिर. डॉक्टर निजामुद्दीन इज प्रेजेंट.
Okay, sir.
Very much present.
Okay, thank you.
Okay. I think it's better to invite someone else.
Yes, please.
Okay, sir. Okay, sir. I call to paper ID 2808. The paper title is Domino FinFET based low power digital circuits at nanometer regime and analysis. The author of this article, Adil Zaidi, Mujib Khan, Muhammad Saeed, Muhammad Shahid, Dr. Muhammad Shahid. The presenter of this article, Mujib Khan, please present your article.
मुजीब खान मौजूद है? Are you present, Mr. Mujib Khan?
Some technical issue. I next call to again the Mr. Naseem. Please present your paper.
Hello.
Yeah, Naseem is present. I think you can continue, Naseem.
Respected director sir, chairpersons, and all of one presented here. Assalamu alaikum and a very good afternoon. Today I am presenting on CNN-based eye center localization. I am Naseem Ahmed, assistant professor in Mewat Engineering College and PhD part-time research scholar at NIT Silchar. Now, this is the content page. So hope I'm going to next slide. That is introduction. And my topic is CNN based eye center detection. What the use of this eye center detection and why we are using deep learning neural networks. So accurate eye center localization can be quite useful in human computer vision, driver drowsiness detection, and gauge estimation applications. I want to elaborate about driver drowsiness detection. We can overcome the accident rate using the driver drowsiness detection if we install some instrument kits or in the moving vehicles. So eye center detection, basically it's a challenging task due to specular reflections, varying illuminations, and possible occlusions. Specular reflection means like when you are wearing a glass specs and you are taking a photo, then there will be some reflection, white reflection in your eyes, iris, or black portion of the eye. Because of that white, that light, and then when we find the eye center detection, because we are using the characteristics of eye means there is a white portion in eye that called sclera, and there is iris inside the sclera, that is the black portion. So we are using these intuitive characteristics to find the eye center. But when this specular reflection fall on the eye photo, then it will difficult to find the eye center exactly. And eye center prediction plays a crucial role in human computer applications. Even eyes are more stable features. Like we are using Android phones that can be open with our face detection, or that runs on the iris features. Like it will detect our eyes. Sometimes your face, your mouth, and it can be changed. But eye centers, that is the stable thing in your face. So I am presenting a novel method to accurately detect eye center detection using deep learning or convolutional neural networks. So it's a literature survey. Now come to the proposed method. Yeah, my point is I am here using the deep learning neural networks, the CNNs. And what is the difference between CNN and all the machine learning algorithms? The main point is like deep learning neural networks, CNNs, will extract the features or high level features automatically. Like if we are training in machine learning networks, we have to make a model, train a model, and then it will predict the eye center or something. But in deep learning method, we don't need to give the features. It will take automatically. So this is the proposed method. Now there is eyes and non-eyes, but the main disadvantage of deep learning neural networks is that like we have a lot of data. If we could not have a lot of data, and we are using deep learning, then it will give the result, but the result accuracy will not be stable. So here in proposed method, I am training a CNN model, and with the eye and non-eye, I am using in this paper approx 7,600 eye parts, and approx 22,000 of non-eye database. And here we are using convolution layer with ReLU. ReLU is a rectified linear unit. It is an activation function used in CNNs. The basic function of this ReLU function is to make the negative values as 0 and all the positive values as it is. So convolution will here we are taking the convolution of 3 cross 3 box, and multiplying run it on the whole eye and non-eye images, and the eye and non-eye images I am taking 30 cross 40 of the patches of eye and non-eye database. And next is max pooling layer. Max pooling layer is the next to the convolution and ReLU layer. It will give me the maximum value out of the that convolution that multiplied with the actual image. Then from that it will give the maximum value. And here are two more things: stride and pooling. That is another thing. But stride means you are moving from pixel to pixel. Like if you are giving stride value 2, then you are moving leaving the 1 pixel value, and then you are moving to that your convolution moving to the next part of the image. Next next is convolution to ReLU plus ReLU max pooling, and then again we are using convolution 3 and ReLU functions. So it's a model that I actually designed this model with the help of MATLAB, and there is a tool in MATLAB that is deep learning neural networks. So again, from the MATLABs, actually what I am doing here is like it's an image, it's a 2D image, eye and non-eye. I am extracting the high-end level features from the eyes and training a model, and it will automatically taking the features. And it's a FC. FC is a fully connected layer. It represents the feature vectors from the input value. It will convert the feature vectors in a 1D value. And softmax layer, it converts the scores to the normalized probability distribution, which can be displayed to a user or used as input to the other systems. Then output of the fully connected layer is given to the softmax layer, and the function of softmax layer is to convert the its normalized probability distribution. Then it will go to the classification layer. Here I am using classifier learner, binary classifier learner for eye and non-eye classes. Uh, um, we can use also transfer learning here with the already trained neural net, and then we can use can change the output 2 layers of that classification layer, and then so that is the my proposed method. Next is experimental framework, and I am using a database, BIOID database, that contains 1521 face images of 23 subjects, and the size of the each image is 384 cross 286 pixels. And there is a NERR, normalized error location, I location error, that can be calculated by Euclidean distance between left and right eye, and that will be formalized max of d left, d right divided by DIOD. DIOD is the interocular distance between two eyes, left and right eyes, and we are taking here DIOD as 75 pixels, and the ground truth values of the left and right eye are so given to the database. So we can calculate the recall and precision. On behalf of recall and precision, I am giving the result section. So this recall can be calculated as true positive divided by true positive plus false negative. True positive is called like it is actually predicting the right value, and false negative, it is maybe predicting I, but it is not I, it is giving false result. So we can calculate false and precision. The results and discussions are here. So I am taking the R as a three values, 0.05 and 0.10, and NERR less than 0.25. This is the 0.05 means we are getting the eye center detect point nearer to the ground truth point, and if the predicted value is outside is away from the ground truth value, then it will be the error will be the more. So I am taking the 6 papers. On behalf of that, I am giving a comparative analysis, and I can say my paper can give a good results as compared to other. These are the Joe et al., Zia, Valenti, Kim, and June. These are using the machine learning models. They train the model, and they extract the features, already features, and then lower, you can say low level features, and after combining and merging of the features, they are extracting the eye centers. But in my case, I am not extracting the features. CNN is automatically extracting the features and then training the model, and on behalf of that training model, I am in the verification part. I am extracting the precision and recall, and on behalf of precision and recall, I am getting the values NER and this. So if I am taking the NER less than equals to 0.25, my accuracy is 99.95. Now conclusions. Yeah, it gives us the high level features, but still there is some problem, and then problem is about the computational time. If we are running this deep learning neural networks on the image, then it will take time. Approximately it will take 8 seconds to run the code, but I am not mentioning the time here. And there are some predefined values, like I am extracting the eye center for that cases that not wearing the glasses. So maybe for that the error will be more, but I am not considering the case here. So this is enough from my side, and anybody if have questions, please ask.
What's the role of activation function in machine learning?
This is rectified linear unit. there are a number of activation functions, but I am using ReLU. It will give me the values from, if we are getting the output from convolution, multiplication of convolution with image, then it will give us maybe positive or negative values. But ReLU will do, it will make 0 all the negative values, and it will take as it is for the positive values.
Okay. Is there any other question? Okay, well, thank you, Naseem. Dr. Junaid, please
Thank
invite
you,
someone
sir.
else.
Thanks a lot. Okay.
Welcome.
Thank you.
Okay, thank you, sir. I call to next one. The paper ID is 2828. The paper title is Development of Remote Access Open Server with AES
मेरा नहीं है यार
256 with private keys on Raspberry Pi. The author of this article, Sudhir Dabra, Sher Jung, Manisha Kushagra Singh. The presenter of this article, Sudhir Dabra. Please present your article. Dabra sir is available. Mujib Khan is there. Mujib Khan.
Yes, sir.
Okay.
I'm here, sir.
The paper ID is 2808. The paper title is Domino Effect based low power digital circuits at nanometer regime and analysis. The authors of this article, Adil Zaidi, Mujib Khan, Mohammad Saib, Mohammad Shahid. The presenter of this article is Mujib Khan. Please present your article.
Good afternoon, everyone. Sir, please make sure that my screen is visible.
Yes, it is visible.
Okay, sir. This is Mujib Khan. I'm from BTech, 5th semester Department of EC Engineering, Mewat Engineering College. Today I'm going to present another reviewed paper, Domino FinFET based low power digital circuit at nanometer design and analysis. The prime objective of this work was that we have studied that there are lots of effects in the CMOS, ordinary CMOS circuit. So we have replaced the bulk CMOS to the FinFETs, and there are also some leakage is taking place in the FinFETs. So we further try to reduce all the leakage and power consumption in the FinFET logic circuits. So in this paper, we try to simulate domino-based FinFET logic circuit at 32 channel length with the help of H-Spice simulating tool. As we know that static CMOS logic having a larger area, and in the static CMOS we are always have a static power leakage and high parasitic capacitance and higher delay. So we replace the static CMOS logic to the dynamic logic, but there is some also problem in dynamic logic, that charge leakage problem and charge sharing problem and clock skew problem. Charge leakage problem is that whenever we are taking the output through the load capacitor, then this capacitor is not an ideal capacitor which cannot retain the stored information infinite time, it slowly degrade the stored information through the ground. And there are some other charge sharing problems, like if we are giving an input to the circuit, then all the charges of the X node is distributed between the inputs A, B, C, D, and further. So the charge will reduce so much low that the output will start to assume that the low input is feeding is low. So that's a problem in dynamic logic. So we introduce inverter between the both stages. So the first when we apply a first clock to the circuit, and then after the this X node is low, which will discharge through the through the ground by the path of AB is short circuited in the mode of evolution. So the next circuit can start. The advantages of domino logic circuits are they consume very less power, and because of there is only need of 2 plus and transistor extra, so we can reduce the number of transistor being used in a circuit, and which will lead to higher packaging density. And there are some other advantages of domino logic circuit are they are much higher than normal static circuits. And there are some disadvantages of non-logic circuit that we have to introduce inverter buffer in every circuit. And as we know that this load capacitor is not ideal capacitor, so we cannot retain the information as long as we want. So we have to make ensure that the switching frequency of our operation should be very high. It cannot be minimized from a certain limit. We have to always keep it on a high frequency. So there are some other problems in domino logic circuit which have been reduced in these proposed circuits, and proposed methodologies are discussed in the paper. The first circuit we are discussing is, first of all, this circuit is based on the FinFET technology, not on CMOS technology. We replaced all the CMOS with the FinFET. And the problem was that in the case of parasitic capacitor and other unwanted sorting path, which we are having to VDD to ground, which lead to the discharge this circuit to the ground. So we just use a keeper transistor to pull up this network always whenever any leakage current and other kind of noise try to pull down this dynamic node. It will on the PMOS, which will charge this dynamic node to BDT. Hence, the problem of leakage of charge sharing and charge leakage is resolved with the help of this circuit. This PMOS circuit is very low, very big. We can say that the very high resistance of the keeper circuit is used. And another NMOS circuit is connected to the ground, which provide a higher immunity in the leakage current. And further, there are some modifications in the footed domino logic circuit. We have removed the footed domino circuit in this footless domino circuit, so the number of transistors can be reduced in this circuit. As we saw in the figure, that there is only 2 transistors are used basically to design this circuit, and this is much higher. But the problem is with that we have to compromise with the noise immunity with this circuit in this circuit, because there is a path, direct path. If we are getting any noises and any kind of ground path, then it will discharge to the ground. But it takes place slowly, and there are some less transistor we can use in the circuit. This is the advantage of the circuit. And there is another type of domino logic circuit in which we are using a clock delay to ensure that the keeper transistor on at the evolution phase. Actually, in the pre-charge phase, we have seen that this keeper transistor is always on, which is unnecessarily consuming the power. So we tried to minimize that power by using this delay and some kind of circuitry. So this keeper transistor should remain off in the early phase of evolution, because we don't need any pull-up circuit in the early phase of evolution time. We only need it after the this dynamic load get grounded or get discharged through the ground. So we use the keeper transistor, and we connect it to a delay element. So we can provide a delay whenever the evolution phase is taking occur. So this is also a very good kind of domino logic circuit. And there is another kind of domino logic circuit, is that a conditional keeper domino logic circuit. In the case, we can see that in the previous circuit, that the keeper transistor was on all the time unnecessarily. If we don't need a kind of pull-up network at the early age of the phase, evolution phase, then we should minimize this power. So we divided the keeper transistor into two parts. We divided into a larger part and a smaller part. In the early evolution phase, we keeps this MKP1 off. So the smaller keeper transistor should remain off in the early phase. Then whenever the evolution phase has completed, and the larger keeper transistor will be started and in the on condition, and will charge this dynamic node to the BDD. In this case, we can reduce excessive power consumption and another power consumption, like which was consuming by this keeper transistor. This is a proposed circuit which was proposed in this paper, and in the case of this circuit, we have further modified the keeper transistor. We divide it into the two parts. And in this circuit, we have used the ultra low power stack design with the combination of PMOS and NMOS in series, so the leakage power can further be reduced to the minimum value. As we have seen the result of the circuit in the graph, that we can found that the proposed circuit are providing and offering less power consumption and less average delay in the circuit. We can see that with the help of this graph demonstration, it's shown on the figure on the screen. There is another proposed circuit which is being designed by the using of independent gate FinFET keeper, because we can use FinFET in many manners as according to our desirable output. So in this case, we used both of the gate of the FinFET keeper in independent mode. So the both of the gate can work independently in this mode. Once we are having a
Hello.
Yes. Hello.
Mujib Khan, please continue.
I think there is
Your
a network
voice.
problem.
Oh, yes.
Let's wait. No problem.
output of
Hello.
Mujib, you please continue. Your voice disappeared.
Hello.
Mujib, can you hear me?
Hello.
Yes, Mujib.
Yes, sir.
Can you hear me?
Yes, sir, I can hear you.
Yes, now you can continue. I think there was some breakage in your voice earlier, but now it is fine. You please continue.
Okay, sir. My screen is visible now. Hello, sir.
No, the screen is not visible.
Okay, sir. Wait, I'm starting this again.
You share it again, please. Your voice is clear.
This again. Okay, sir. Thank you.
Now your screen is also visible.
Tell me.
Yes, it is visible.
So resume to the
actually,
place
I
where
lost
it
my
was.
flow. Please, sir, can you tell me that when my sound was break
No problem.
at my PPT?
You can conclude now. I think you have already taken 5 minutes. You can conclude now.
Okay, sir. Okay, sir. I was at the end of my presentation. In this circuit, this is a proposed circuit in which we have used a NAND gate, which provide a special kind of function of this FinFET keeper transistor, which always allow a single gate of the FinFET when the single gate of this keeper is on. The threshold voltage is very high, so there is no leakage in this keeper transistor, and due to having very high threshold voltage, it is having less power consumption, because both of the gate work independently in this mode. So actually, sir, we have seen in this circuit that we can vary the size of keeper transistor. We can vary it according to our desire. So in this proposed circuit, we have varied the keeper transistor size, and we can see in this PPT that in the graph that we with the varying of the keeper size, the power consumption is getting low, and the delay evolution delay is also getting decreased. In this kind of circuit, we have get the 46% reduction in the power as compared to other circuits like standard tie gate. In the standard tie gate and comparing to the proposed independent gate, we are having a 46% of reduction in the power, and delay also reduced significantly. However, there are some degradation in noise margin, but they can be considered very low. Conclusion of this paper is that we have explored the circuit at a 32 channel nanometer channel length with the help of HSPICE, and power consumption we can say that very low, and in the circuit in the first circuit we found that power consumption was 30 to 38% reduction, and in second paper we can say that 40 to 46 to 48% reduction of power is being shown. All the simulation are done at the power supply 0.9 volt, and at the software of HSPICE synopsis tool, and these are the references which I have taken all the data and study which I referred in my study and investigation. Thank you, sir.
Is there any question?
Thank you, sir. If there is any question regarding to
Anyway, how FinFET reduce short channel effects? Give a brief review, please. How FinFET reduce short channel effects? Sir, with the architecture, we can say that we are having an FinFET 3D architecture. The channel was in the planar CMOS. The channel was lying horizontally underneath the gate. But in the case of FinFET, we are having a vertical channel, and also we surrounded the channel with the two gates. From the both side of gate, we are controlling the channel. So we can say that by using two gate or multi gate and kind of thing with surrounded gate, we can reduce the short channel effect in the field of FinFET transistors. Okay. Okay, thank you.
Thank you. Thank you, sir. Thank you.
Okay, welcome.
Can I proceed, sir?
Yes. Invite other one.
Okay, thank you, sir.
Okay.
I call to paper ID 2828. The paper title is Deployment of Remote Access Open VPN Server with AES 256-bit private keys on Raspberry Pi. The presenter of this article, Sudhir Davra. Please present your article.
A very good evening. Are you getting my voice? Yes, Davra
Yes,
sir, we are getting your voice. Okay, okay. A very good
Please
evening.
continue. Yeah.
Okay, a very good evening, respected sir. I'm going to present a paper titled Remote Access Open VPN using Raspberry Pi. In this paper, we are describing about the VPN. What is VPN? That is Virtual Private Network. How Virtual Private Network provide the security between the internet and the user. In this paper, we will discuss the VPN overview and types of VPN, Open VPN, Raspberry Pi, what is the significance of Raspberry Pi, how we have implemented in our paper, how we have deployed this, and what are the merits and demerits of Raspberry Pi, and what are its application. In this VPN, virtual private network, firstly, I'm explaining what is virtual private network. In virtual private network, it stretches out a reserved network over public network. That is point-to-point secure channel encrypted using various algorithms. In this, you can see a person can access with the internet through the VPN, and VPN provide the security, and it secure the network, secure the internet from the hackers and snoopers. As well as you can see the connection overview in which local network, home network connected to the another network by the using the virtual private or secure channel. In this, VPN provides the total security to the user so that user can access the server or take the information from the server by without compromising with the hackers or snoopers. In this, you can see a side-to-side VPN connectivity overview. We are discussing in this branch office is connected to the corporate headquarters, and VPN is the backbone of any organization. In VPN, you can see VPN is the backbone of any organization. VPN is placed between the user and the corporate headquarters. Moreover, you can see there are different kinds of VPNs are available. Firstly, we have discussed a side-to-side VPN connectivity overview, in which you can connect one site to the another site, and another site connect with the corporate headquarters. This is one of the type of VPN, virtual private network. Another type is a remote access VPN connectivity overview. You can connect the VPN gateways with the corporate LAN, and you can connect different road barriers to the hypertext transfer protocol over the secure socket layer. Secure socket layer basically provides the security for the transferring of message, as well as multiple applications over SSL have been implemented. In this, you can see the VPN client provides the security to the VPN gateway. And Open VPN, that is the third type, Open VPN, in which open source commercial software that implements VPN, and we have used open source commercial software that implements VPN, and it can be used with site-to-site or remote access VPN. It uses a custom security protocol that utilizes secure socket layer for the key exchanges, and that is available in various kinds of platforms, various kinds of operating systems. Few of the operating systems
My voice is coming. My voice is coming.
Yes, you are audible, sir. Continue.
Okay. Thank you. Then I'm discussing about the Raspberry Pi, which we have implemented. That is cost-efficient credit card size computer, which we can implemented in our paper. That is very important. Raspberry Pi, that is similar functionality as that of computer. When a display is connected using HDMI and input devices are connected via USB. Through the USB, we can use Raspberry Pi for maintaining the security between the user and the internet connection, so that you can make it as a virtual private network. This is a deployment overview. This is a home user, and through the home user, we can use this Raspberry Pi. We have deployed open on the VPN server, and Raspberry Pi provide the authentication that which are the actual users, which are the right persons, which are authorized to access the internet, and through which we can implement the VPN, virtual private network, and Raspberry Pi is deployed in between the home user and the internet. Apart from firewall, it provides the security so that unauthorized user cannot access this. This is, as I have discussed in my previous slide, that is credit card size computer, and it provides the security between the user and the internet. These are the merits of Raspberry Pi, that is very cost effective, and that is eliminating the need for expensive long distance lease lines, which we have to use if we want to communicate with the server. That is greater scalability, one of the best feature of this Raspberry Pi. It is easy to add, easy to remove users. We can easily add the users, and we can easily remove the users in the network. We can add feature is security. For the security purpose, we use the Raspberry Pi, and that is transferring the support burden to the service providers. Demerits are understanding of security issues. It sometimes compromises with the security. Unpredictable internet traffic. It is not easy to identify the traffic, how much traffic is on the internet, how much traffic is coming, and it is difficult to accommodate products from different vendors. Lack of standards, that is also a demerit of this Raspberry Pi. VPN need to accommodate protocols other than IP and existing internal network technology. So these are the few drawbacks of this Raspberry Pi, which we used between the internet and the home user. Apart from this, these are the application side-to-side VPN. This is large-scale encryption between multiple fixed sites such as remote access offices and central offices. Network traffic is sent over the branch office internet connection, and this saves the company hardware and management expenses. We need not to use so much of hardware, and management had to spend less amount while implementing the network between the home user and the internet. In this Raspberry, we will implement different kinds of algorithm to make the this is a card, and we can implement between the internet and the home user. And this is an application of remote access VPN, that is encrypted connections between mobile or remote users. Remote users can directly communicate with it. Remote users can make a local call to an internet service provider as opposed to a long distance call to the corporate remote access servers. Apart from this, it is ideal for a telecommuter or mobile salespeople. Mobile commuter salespersons can easily maintain the security by using the Raspberry. Thank you so much. Thanks a lot. And any question?
Is there any question from audience, please? Anyway, sir, please give a light on VPN encryption from security point of view. VPN encryption.
Which one?
VPN encryption.
Encryption is a technique to convert the plain text to the ciphertext, and then when it is reached to the destination, it is again converted to the ciphertext to the plain text, and the technique is known as encryption and decryption. And it is also implemented in the RSA algorithm, through which we can implement the security in which we convert the plain text to the cipher and then cipher to the plain text.
So we can implement it in VPN also. So still you have told us that it is not secure. So
No,
what can we do?
actually, I am sharing all the merits of I have covered all the merits of VPN, virtual private networks. But in some cases, when we are talking about the long distances, when we are talking about the strengthability of the channel, then sometimes it compromises. That's why I have covered that it sometimes security issues are also raises in this VPN.
Okay, sir. Thank you. Thank you. Nice. Is there any other question? Okay, sir. Thank you. You may quit.
Thanks a lot.
Welcome.
Good
Welcome.
evening. And
Good
thanks
evening
the
to you,
organizing.
sir.
Thanks a lot for the organizing team for organizing this wonderful conference. Thank you so much. Thanks a lot, sir.
Thank you.
Thank you, sir. Can I proceed?
Yes, yes, yes.
Okay, thank
Who
you,
is the
sir.
next presenter?
The paper ID is 2517. The
Okay.
title of paper is Machine Learning Based IoT Security System for COVID-19. The author of this article, Raju Krishna Kant Singh Gautam or Rajendra Kumar. The presenter of this article is Raju. Please present your article.
Good afternoon, everyone. So my topic is machine learning based IoT security for COVID-19, and it is presented by me, and the other authors are mentioned in the slide: Raju Krishnakant Singh Gautam and Rajendra Kumar.
Please press F5.
Okay. Sir, actually, keyboard is not okay. It's done, sir.
Okay.
So the machine learning based IoT security system for COVID-19. As we know that the COVID-19 has become a pandemic and become a big problem for all the countries. So we try to predict the condition of a person on the basis of his travel history, his age, and medical history. And first of all, we decide to work on the features or the symptoms that we found in the COVID-19, like fever, cough, sore throat, or difficulty in breathe, chill, muscle pain, new loss of the taste or smell, etc. These features we selected for our paper, but unfortunately, during the lockdown, we are not able to get this data. So in that case, we choose some social region that become a big cause for a spreading of COVID-19. And as per that, we selected number one is the travel history. Travel history means the person who are traveling from here to there. So it is classified into three part: imported cases. It means that the COVID is coming from foreigner countries. So by flight, it is coming to the our country, and after that, that person go or meet to some other person. So that become the primary contact for the transmission of the COVID-19. After that, they will move to the different places, religious places, shopping mall, or any other places, and this type of COVID-19 is spread up over there. And as per record, we saw that in Maharashtra, on the basis of the traveling, the most of the, I mean, 54% travelers become the cause of COVID-19. Among of them, few are COVID patient of COVID-19. So in that case, we analyze this data. So we take one parameter for our analysis, that is the travel history, and instead of keeping it in fuzzy, we convert into a discrete value so that we can train our model. The next thing that we take is the age. So when we consider the age, so we saw that around 60.7% people who are suffering from the COVID and unfortunately they go die. So they are of age of 60 to 79. But this rate is low in our age group of the 0 to 19. So we also keep this parameter in our analysis part. And next one is the patient history, or we can say that the medical history. It means that if person is already suffering from some disease like diabetes, hypertension, heart attack, or kidney problem, etc., etc., so he is the easy target for COVID-19. So on the basis of these three features, we train our system, and for that we numericalize our data instead of taking them into the fuzzy like this. Uh, and for that, these are the parameter that we use to find or check the accuracy of our model. Accuracy, precision, recall, F measures, specificity, false positive rate, and all these things. And to simulate this thing, we use the Python. In Python, we give the data, and initially data is not easy to collect. So we contact some companies, or we contact some person who are personal, who came from the abroad, then talk to him on phone, because personal contact is not possible over there. So we took the data from that, and we make around 200 to 250 data. So on the basis of that, the accuracy is here. So this is done by two classifier or machine learning based technique, that is the KNN, and another one is the naive Bayes. So on the basis of that, we create precision, recall, and other parameter of the accuracy. And the approach that we used is this. In starting, we are trying to collect IoT data from the IoT devices, so that we need not to contact with the person. And when we collect that data like a temperature sensor and other devices, so we classified that data, and we select some features, train our own model, and on the basis of trained model, we get the accuracy, and we fix our accuracy up to 97%. It means that if we getting accuracy greater than or equal to 97%, then this is an alerting for the neighboring person of the person. It's just like Arogya Setu app that just alert the people who are around a COVID patient. So if it is not up to this, then it will consider the device as a safe, and then deny the access. These are the classification through the KNN, and here I saw an example that the red dot that you are seeing, this is our new data that we give to our trained system. Then after that, this data is go to a cluster, to that it is belong. This is naive based, and this is our results based on the KNN and naive based classifier. So after that, by analyzing these, we conclude that the KNN is better classifier than naive based. So we perform our analysis of data for the COVID patient on these two classifier. In future, the researcher can also work on some other classifier to predict the condition of COVID patient. Thank you. Thank you very much. These are the references. Thank you.
Is there any question? Anyway, what are the security issues in IoTs?
Sir, basically security issues की अगर हम बात करते हैं तो they are on the different layers, sir.
Yes.
So different layers means physical layer, network layer, and transmission layer. So all are today is not safe, because IoT is the recent topic which is now started. So there is lots of issues like authentication. There is no proper authentications, and the lackness of the users who are using the IoT systems. They are not aware about the latest technology, that when they purchase an IoT device, then they have to change the password, which is by default feed into the system. So there are various authentication or confidentiality, integrity problems with the IoT devices that we have to work.
Okay, thank you.
Thank you. Thank you very much, sir. Thank
Please
you.
quit. Okay, now invite another one.
Hello, sir. I want to some question.
Okay, no problem. Yes, go ahead.
Okay, okay, sir.
Number of classifiers are there, but why use the KNN and NB only?
Sir, actually, these classifier has already work on some data. So we are just trying to work on these two one, which are the basic and which are also easy to understand for a common or a normal who is studying the machine learning, who have a little knowledge of the machine learning. They can also understand this topic.
What is the better technique of
Sir,
this?
in this case, the KNN, as the result shows.
Okay.
Any other question from anyone? Okay. Thank you, sir. Thank you very much.
Okay.
Sir, give me permission for the next participant.
Yes. You can invite,
Okay,
need not to
thank you,
ask.
sir.
Okay.
I call to paper ID 2830, modeling and optimization of hybrid energy system for rural electrification in isolated region using Homer software. The author of this article, Muhammad Mustafa Kamal Imtiaz Asraf. The presenter of this article, Mustafa Kamal. Please present your article.
Now I am audible?
Yes.
Okay. Good afternoon, everyone. This is Muhammad Mustafa Kamal from Aligarh Muslim University, Aligarh. I am going to present my topic on modeling and optimization of hybrid energy system for rural electrification of isolated region using Homo software. These are the outline of my presentation: abstract, introduction, study area and load assessment, problem definition, results and discussion, conclusion and references. So, renewable energy resources are extensively used for the electrification of rural community. Uh, the integration of locally available energy resources are the best option to provide the reliable and economic power supply to the area where grid extension is not possible. In the present work, we are going to study area where grid extension is costlier or is not possible to provide the electricity by grid extension. So in that area, we basically provide the electrification by integration of available energy resources in the vicinity, such as PV, wind, battery, and diesel generator, and optimize the total cost by using Homer, and studied the different variation of different parameters by using Homer software. We are living in a developing country like India. The bulk of population is living in rural area where grid utility extension is not possible, or it's very costly to provide the electrification in that area. If electricity provided in that area, uh, electricity can improve the life of that area by using irrigation, food preservation, crop processing, cooling, and small scale industries, which not only enhance the living standard of the area but also increase the GDP of our country. But in hill area where building of grid infrastructure is not possible or it's very costly, so in that area electrification by available renewable energy resources in the vicinity is the best option. For the case study, for the electrification in rural area, isolated area where grid extension is not possible, we have taken 12 unelectrified village in Uttarakhand district in Tehri Garhwal. In Uttarakhand district, most of the population, most of the rural population are uh, electrified by the either renewable energy resources or available energy resources in the vicinity. So for our case study, we have taken the 12 unelectrified villages in that area in Tehri Garhwal district. The meteorological data of that area is shown in figure. First figure shows the average monthly temperature, second isolation and clear index, third monthly wind speed of that area. The total load assessment assessed the total load of the area assessed by the door-to-door survey of the area. The total load consists of agriculture load and daily load, which is shown in figure. The problem definition: the microgrid is an alternative to provide the electrification of that area by integrating the available energy resource in the vicinity to electrify the local community by using solar, diesel, and storage device in stand-alone mode. The proposed model is provide reliable and economical electrification of rural energy region. A storage device used to store the energy when production is high or surplus amount, and it can provide the energy in peak hour. The schematic of our present case study system is shown in figure, which we can see the diesel generator, wind turbine, PV, lithium-ion battery, and load of the area. A specification of component used in modeling of the system is shown in table. The rating and the capital cost, replacement cost, operation and maintenance cost, and lifetime of different components shown in figure. The simulation is a simulation done by using Homo software. The result and discussion the proposed system is provide reliable supply of electricity for the rural community. The result of the optimized case analyze as well as sensitivity of the system analyzed by varying different different parameters of the component. For optimized case, the capacity of PV is 6.88 kilowatt, lithium-ion battery has 43 number of strings, and diesel generator 10 kilowatt. The total cost per unit cost of energy is 0.6122 and net present cost is this. The variation of total cost of component shown in figure, the first block shows the total system cost, and another respective block shows the component-wise distribution of total cost. This is the monthly electricity production by the different components. Green figure shows the diesel, yellow shows PV, and blue shows wind turbine monthly production of energy, 1 kilowatt form. We know the Homer software provides a combination of different energy resources. So in this table, we can see the different combination of energy resources, but our optimized cost, we see the per unit cost of energy 0.612 with NPC this. With the market price of variation of diesel price, we considered for the analysis of our system, solar radiation variation, wind speed variation, and analyzed by the Homer software. We found the different combination listed in table. So in the conclusion part, in the present work, an integrated model of energy system which consists of solar, wind, diesel, and battery system proposed to electrify the rural community where grid extension is not possible. The proposed microgrid system worked in a standalone mode. The study of energy system carried out for the 12 unelectrified villages of Uttarakhand state of India. The simulation results suggest the lowest cost of energy is $0.6122, and with total net present cost is 173329. For the feasibility study of the system, different combination of energy resources analyzed by using software, Homer software, it is found that to electrify the rural community proposed system area, PV, wind, battery, and diesel system provide the list cost compared to the other combination. The sensitivity analysis, for the sensitivity analysis, we varied the diesel price and other parameter for our survey. This survey is better for the planning of rural community where grid extension is not possible. These are the references. So now you can ask question.
You have not explained your proposed model. Please briefly explain your proposed model.
Sir, actually, this is a case study which I have carried out for the Uttarakhand state.
There was a
steady
diagram.
level.
But there is a diagram. Yes, yes. Go back. Go back. Yes, yes, yes.
Yes, this.
Yes, this one. This one. What is
This
this?
is where we have taken in that area the grid extension is not there. So we provide the electricity by using available energy resources, that is PV, wind turbine, and for the backup we provide the diesel generator, and for the storage we use lithium ion battery. So this is the low in hilly area. The population is very rare, means low population. So only few villages are there. So this schematic is this schematic available. This schematic fulfill total amount of their requirement in that area.
Okay. This is basically a representation of a case study, right?
Yes, yes, yes.
So, but your title is modeling and optimization of hybrid energy system. So how will you compare these two?
Actually, this is the modeling. In our software, when we provide the different blocks and available in that simulation, so this is called modeling.
Yeah, that is all. Where is a model? When you are using a word modeling, so you should use a model and then try
It's
to
not, sir, like that. MATLAB we use component level modeling. In Homer software we can only choose drag and drop system.
it is like Simulink.
Yeah, but in Simulink we can model. In component level modeling means you can model register or etc whatever component you are using. But in this we have only provide data. If you have data in that particular area, you will got the exact result. Exact means you got simulation result in that area. Maybe real result will vary, but somewhat you will get that result in this case.
Okay, thank you. Is there another question? Okay, Mustafa, thanks a lot.
Okay, thank you.
Hello, sir.
Now let's invite other one.
Okay, okay, sir. I call to paper ID 2829. The paper title is Synthesis and Analysis of Various Modulo Address. The presenter of this article, Dr. Shaheen Khan. Please present your article.
Visible, huh?
Yes, your screen is visible, but presentation is not.
Yes.
Please share your presentation.
My voice is visible, Nizam sir?
Yes, yes, yes.
Is it appearing correctly?
Yes, yes, correct. Go ahead.
So the paper title is Synthesis and Analysis of Various Modulo Adders, and the authors are Shaheen Khan, Zainul Abdin Jafri sir, Khwaja M. Rafi sir, Irshad Saab, Nadeem Ahmed. And we are presenting this paper on behalf of these authors, all co-authors, in the conference Rtreaet 2020, which is holding at Mewat Engineering College. So first of all, the introduction. In this, we are using residue number system. Residue number system is a non-weighted number system, mostly used in digital signal processing systems. RNS is suitable for FPGA implementation due to concurrency, modularity, and fault-tolerant properties. So these are all the properties of RNS system. One of basic property of RNS is that basic operations like addition, subtraction, and multiplication can be easily equivalently performed concurrently. Concurrently means we can do it parallelly, irrespective of all the channels. RNS deals with small residues of relatively bigger natural number, say x. So if we have some bigger number, say for example 20, and if we want to take its modulo with respect to 5, then it will be 0. So corresponding to that, if we process 20 and if we process 0, so definitely it will be a big change as far as implementation is concerned. So basic modulo addition operation, this can be described by the equation which is shown over here. This has got two approaches mainly. One is the serial and another one is the parallel. So serial, as we know, it is efficient in hardware implementation but slower. And we know about the parallel, it is always faster, but it is always more in hardware. Basic modular addition can be expressed using the equation that is appearing on the screen. So here we can see Zm, M means the modulo, X plus Y means the two operands we want to add. If it is if the summation X plus Y is less than M, then it will be X plus Y. And if the summation is say greater than M, then in that case what will happen? We will represent it X plus Y minus M. So I can take an example for that. If suppose we have 5 plus 7, so it is 12. And if I take the modulo with respect to 3, then it will be 0, because 12 will be divided by 3. And the number which remains in the end will be 0, because it completely divides it. So this is an example. Basic modulo addition operation. This can be described using two approaches. The first approach is the serial addition, and the second one shows the parallel one. In the serial one, we can see we add X plus Y, adder A, and then the result is used for adder B. In the right hand side, we can see the operands X plus Y are added over here, and in the second adder B, that adds X, Y, and M bar. So separate addition is taking place. Once result is not affected by the other one. So this is parallel modulo adder, which is shown in this figure. Other modulo adders, these are some other discovered in the literature. Boyomi and Julian's modulo adder, which is shown over here. It uses two basic adders and one OR gate and multiplexer. And another one, which is very popular one, is the LUT based modulo adder. So here we use the LUT corresponding to the addition that is taking place with respect to X and Y. Now this is the diagram which shows a bigger complex adders. Say for example, Hiyasat modulo adder, and another one is the TCR based modulo adder. So in this we can see various sections are there. SAC adder, SAC, first of all, the first section that represents sum and accumulate, and then CPG represents carry, propagate, generate, CLA for C out, carry look ahead for C out, and MUX multiplexer, CLAS means it is carry look ahead and sum. So this is the representation of various blocks. And in figure 5, TCR based modulo adder is shown. This shows that a TCR code can be used for the addition of two numbers. So one number will be represented, say B1 to B6, and another number which is also TCR can be represented using S4, S2, and S0, the bits which are shown over here. And then some appropriately based on the bits S4, S2, and S0, the rotation take place, and this is shown in case of 2:1 multiplexers. Are the data is rotated accordingly as per these bits, binary bits. So finally the result is obtained R6 to R0. So these are again the TCR bits. Now OHR based modulo adder, this is again based on 2:1 multiplexers, and it is here shown for M equal to 7. And then finally each and every addition take place using carry look ahead adder. So this is shown in the figure 7. This is very popular one, and this is used as in Boyomi adder as well as in every adder. Wherever adder is word we have used, this particular addition CLA takes place. Then simulation results of the proposed filter. This will be this is shown. Say 1 plus 1 is 2, 3 plus 3 is 6, 7 plus 7 is 14, and if 11 plus 11 is 22, and we are taking it with respect to 15. So here the equation that I have represented earlier, so that particular holds true for this. So by 22 minus 15, that remains 7. So this is something that follows the equation I discussed earlier. So comparative results are shown for various adders, and then performance comparison is shown for different modulos. Performance is taken in terms of area, delay, and power. Area is taken in micrometer square, delay nanoseconds, and power is in microwatt. So this is taken with the help of the tool which is Synopsys Design Compiler. So SDC is used for extracting all these results. So these are the curves that is shown for area, delay, and power. Here I have plotted area into delay, and ADPP, area, delay, power. Three terms are multiplied in order to get a better resolution in results. Conclusion is shown over here. In this, we can see various modular adders have been simulated and implemented using moduli. These are the various moduli values. It is found that lookup based and Hiasat's adder performs competitively, and outperforms the other methods for all metrics. This can be seen with the help of the tables as well as using the graphs. TCR and OHR based doesn't perform good enough when actual implementation is concerned. We have already seen the A into D into B means area into delay into power, that increases quite more with respect to the other ones. So this is the conclusion. These are the key references, and thanks. Nizam sir,
Is there any question from audience, please? Anyway, as you have stated that high-set modular adder outperform others, what are the parameters if we'll compare with others, like with TCR?
Yeah, Nizam sir, I think I have taken area, delay, and power. And area, delay, and power are the main constraints based on which I'm saying that my LUT-based one comes out to be a better adder. And these results are obtained from the Synopsys Design Compiler tool. And also, I have derived two more parameters. One is ADP, that is area into delay, and another parameter is area into delay into power, that I am calling ADPP. So these are derived parameters, ADP and ADPP, and the original parameters which I am getting from the tool is area, delay, and power.
From ADP point of view, high-set is better than TCR or not?
I think TCR performs the least.
Okay, thank you.
TCR performs least.
Okay.
Then I have another paper.
Thank you, Dr. Shahin. Before presentation of next presenter, I convey to all participants in conference, I have shared platform Zoom as well as YouTube. Please fill the form and get e-certificate if you fulfill all conditions of the conferences. Sir, can I permission for the calling to next presentation?
Yes, sir. Yes, sir.
Okay. The next presenter is Dr. Shahin Khan. The title of paper, Speaker Independent Speech Recognition Using Wavelength Transform and Neural Network. The paper ID is 262. Please present your article.
So good afternoon again. Welcome everyone for this presentation. Speaker independent robust speech recognition using wavelet transform and neural network. So this is the title of the paper, and the authors are Irshad, Zainul Abidin Jafri sir, Haja M. Rafi sir, myself, Nadeem Ahmed. So we are presenting this in Rtreaet, organized in Mewat Engineering College, Pallanu, Mewat. So first, to start with the introduction, primary purpose is to design intelligent machines used to convert speech signal into readable text. Two types of speech recognition systems are available: speaker dependent and speaker independent, performed by extracting the feature of voice signal. Applications, various control applications are based on this. So work plan, implementation of speech recognition is divided into three parts. One is pre-processing, feature extraction, classification. So based on these things, three parts, we are dividing the speech recognition. These three parts are simulated with the help of MATLAB R2013A version. A database of 300 words was recorded from three different speakers. Proposed algorithm, this diagram shows the proposed algorithm for this. Speech signal is there, then we will be passing it through the pre-processing block, which comprising of pre-emphasis and endpoint detection. Then we have feature extraction, wavelet decomposition, and wavelet energy calculation. And then finally is the classification. In this, we will be getting neural network testing and neural network training. So here we will be getting the output. So basically, three parts are there, as I discussed earlier: pre-processing, feature extraction, and classification. Then pre-processing, this particular block has two sub-blocks. One is the pre-emphasis, and the another one is endpoint detection. So these are performed in this. Pre-emphasis, as we all know, pre-emphasis is used to boost the energy at higher frequencies. Endpoint detection is used to remove the unvoiced part from the speech sample. So this is about the pre-processing. Feature extraction from voice signals. 300 voice samples were taken from digits 0 to 9. That is, these are 10 in number, recorded by 3 speakers. So 10 digits we are taking, and 10 digits samples, 10 samples of 10 digits, and 3 speakers are taken separately. So that makes it 10 into 10 into 3, that makes it 300. So total 300 samples are present. 300 words are taken, which the words are, digits are from 0 to 9. Each sample was decomposed up to level 6. So decomposition, for decomposition purpose, we are taking 6 in the tool. 6 coefficient for each sample, 1 approximate and 6 detailed coefficients. Feature extraction from voice signals. Dobitsch's wavelet DB4 is used for decomposition purpose. So this Dobitsch's wavelet we are using for decomposition. 1 approximation and 6 detailed coefficients are obtained. Percentage energy corresponding to each wavelet coefficient is calculated. Energy values of 7 coefficients, 1 approximate plus 6 detailed, form an input vector. This input vector is used as voice feature. Decomposition of signal using DWT. So this is all shows how we have decomposed using discrete wavelet transform. Then this shows the example of signal decomposition. The first diagram shows the original signal, and the second one shows the signal after wavelet decomposition. Classification. Neural network is used for pattern recognition purpose, as we have indicated in the proposed diagram. Using neural network, input are classified into a set of target categories. Feed-forward neural network is used with 1 hidden layer, 1 output layer. Performance is validated by calculating mean square error. So here mean square error is something that decides our performance. Configuration of network: number of inputs 7, number of outputs 10, number of hidden layers used 1, number of neurons used in 1 layer 9. Training algorithm. Here the training algorithm used is SCG. Transfer function for hidden layer is 10 sigmoid. So input matrix, we are using this input matrix because, as we have told you, that total sample are 1, 2, 3 up to 300, and we are taking these samples for 1, 2, 3 up to 7. So this is the input matrix that is prepared corresponding to the various input samples, which are 300 in number. Training of neural network. First of all, we have to train the network. A feed-forward network is used for this purpose. Scaled conjugate grading algorithm, that we calling it SCG algorithm, is used for training purpose, as it is already mentioned. Network can be trained for different values of number of hidden neurons. Once a network is trained, it can be used to classify the patterns it has never seen before. So definitely, first of all, the system, the network has to be trained, and then it can classify which particular digits we are talking about. So it will be able to classify whatever digits we are calling. So if I say 10, then it should be able to identify 10. Although we are giving 0 to 9, so it will be able to identify 0 to 9 only. Best results were obtained with 9 numbers of hidden neurons. Results: training, validation, testing. We are using for training purpose 210 samples, and validation for validation purposes 45, and testing purposes 45. So total, if we see the number of samples, this comes out to be 300. 210 plus 45 plus 45, that makes it 300. Accuracy. So this shows the accuracy. Say for example, zeros, total number of inputs comes out to be 30, and then the correct classification it gives for all the 30, and then misclassification, it doesn't misclassify anything, so that's why it is coming out to be 0. Correct classification, that comes out to be 100%. So if I talk about the 1 digit, then total number of inputs 30 we are giving, and then correct classification 30, misclassification will be 0 because it is not giving any misclassification. correct classification will come out to be 100%. So likewise, from 0 to 9, we can see the correct classification it gives. Misclassification always comes out to be 0, so it is not giving wrong results for any digit. So correct classification, it always comes out to be 30 because we are giving 30 total number of inputs. Conclusion: advantage of neural network, ANN and wavelet transform have been utilized. An accuracy of more than 99% have been achieved for word recognition. I can also call it 100% because it is not giving wrong results for even a single sample. Future scope is to use a large vocabulary with great accuracy. So this is the conclusion. These are the references. Thanks.
Any question, please? Anyway, what is mean by combination function in neural network?
Combination function. And the most of the work has been carried out, in the Jamia itself. So
Okay.
I may not be having, about idea of combinational function in this, because it is not used in this.
Anyway, okay, thank you. Now let's invite someone else.
Is there anyone left?
No, sir. No, sir. Here's a complete presentation of this session.
I think we should call upon director, sir. Director, sir. परमिशन ले लेते, क्लोज कर देते. क्लोज कर देते.
So very good evening. Welcome back to this conference again. Dr. Shaheen.
Yes, sir.
Is there anybody left or it's all done?
Sir, it's all done. Now it is the valedictory function that we need to start.
So some questions from anybody, some feedback, some you would like to announce about feedback form for participants?
Yes. I think it is, sir, already done by Dr. Junaid Saab. It is announced by Dr. Junaid Saab. He has already circulated a mail regarding the participant certificates. So the participants has to fill the form, and then after that they will be released the certificates through email only. So he has already announced, he has already mailed. And as far as the certificates of the presenters is concerned, they will again be getting the mail from Dr. Junaid Saab, and they have to fill, participants have to fill it, and after that the certificate will be released on email. So
okay, that's fine. So formally we should
Sir, you will not share the link.
Link for what?
Will
Sir, for participation certificate.
For participation certificate, Dr. Junaid Saab has already sent a link.
No, sir, I'm not getting.
You have not received the link?
No, sir.
I have conveyed to all participants.
Where, sir?
Shared feedback link.
in both platforms as well as YouTube.
Please share again, please.
Okay.
Okay.
You have our email ID, then you can always write to
Dr.
us.
Junaid, you can.
Yes, sir.
Yes, sir.
You can mention that link in this chat box. I think you have already provided one link, so they may see if at all somebody wanted to see.
Yes, sir. Maybe I
Sir,
missed it. Please repeat it.
I think you are not there on this time.
Maybe,
I
sir.
have
So
already,
please share again.
I have
I have
already
already
conveyed
conveyed
to all
all the participants
for
for
this
this
feedback form.
feedback form.
Okay,
Okay, I will
again
again share.
Okay, thank you, sir.
So thank you very much, Dr. Nizamuddin, for your hard work. You really maintain a great discipline during this session, and you have controlled everybody in a very professional way. You have done a very, in a way which is as per the requirement of the chair. So you being the chair of the session controlled everything, and all the participants, I'm sure, must have experienced good taste. Sometimes you were tough, sometimes you were very coordinated with them. You have trained them that what are the professional ethics before giving a presentation. This is very good, and I'm sure that these presenters presentation during a conference, the content of the presentation, rather it is overall performance, because how to start, how to present, how to make slides, what should be the numbering and all. So those inputs you have given, we are really very thankful to you, Dr. Nizamuddin. You are a great researcher. You are doing very good research activities in Jamia. You have been associated with a large number of groups, associations. And we feel proud that you are part of MEC, Mewat Engineering College, and your base is Mewat Engineering College.
Exactly.
You can be a vice chancellor or maybe a higher position, but base is always there with you, which is Mewat Engineering College.
Of course.
So I wish you all the very best, Dr. Nizamuddin, for making good efforts and making a very good balance in the session. So thanks a lot to all other participants as well for making making the presentation during this conference. Our faculty members, our students, the staff members, they have worked very hard in conference, though we had other conferences offline, but online was the first time. Before that, Department of Mathematics organized one online conference. In fact, it was the first time when they organized, but we got the support from outside. But this time, and this is the first time when we have everything in campus, all online processes, Zoom and app, YouTube, control, everything from 0 to 10, everything is done by our own college. So we are very thankful to Dr. Shaheen to take lead, and Dr. Tazim, both the HODs, and Dr. Junaid was very, very active. The other team members, I don't have the name with me, but this attendant, I could not mention your name, but yes, you are there, and inshallah, I will be issuing certificates to all of you. So in the last, once again, very, very thankful the Mewat Engineering, on behalf of Mewat Engineering College, on my personal behalf, I would like to thank each one of you to make this program a grand success. Thank you.
Thank you. Thanks
Dr.
a lot.
Shaheen?
Yes, sir.
Should we break?
Yes, sir. Now I think I should officially close it down, sir. I'll try to, put some names on the board. So
Okay.
I am very thankful on behalf of Mewat Engineering College to our respected chief guest, Dr. Hanif Qureshi Sahab. And this Rtreaet 2020 was presided by Honorable Mohammad Shaheen Sahab, IAS. And then I'm very thankful to our director, Professor Khwaja Mohammad Khwaja Mohammad Rafi Sahab, and then Janab Hijr Sahab for vote of thanks.
Don't forget my name.
Sorry. Sir, you lives in our heart.
Yes, yes. You took my words.
But because we have already, lot of number of audiences present in the conference room, and also there are so many participants who are online, so that, increases my heartbeat, and sometimes I can forget something. So please excuse me for that. We have in the day one,
That's
Professor.
fine. The lighter instrument.
Yes, sir. We have in the day one, Professor Majid Jamil sir as our expert. He's mentor, guide, and everything to us. And then we have Professor S.K. Chakravarti sir as our keynote speaker in the second day, that is today. And in the first day, we have the session chair, Dr. Shiraz Kirmani, who has played the role the way Dr. Mohammad Nijamuddin Saab has played today. So we had we also had Professor Imtiaz Saab, Professor Imtiaz Ashraf Saab today's in the evening session. So these were the personalities who were there in this particular online conference. And these are one who became the pillar of success for this conference. I would like to thank Dr. Tazim Ahmed Khan Saab, who is also the convener with me. And then we have Dr. Junaid Saab, and we have Mr. Shamshad Ali Sahab, and then Adil Zaidi Sahab, and Naseem Ahmed Sahab, and then Shahina Madam, Shahina Bano Ma'am, and then we have Dr. Sham Sundar Kaushik Sahab, and then Umar Khan Sahab, Mohammad Umar Khan Sahab, Faraz Ahmad Sahab, and then we have our technical persons who supported us throughout in this, Mr. Shakir Hussain, and then Hanif Sahab, Liaquat, and then we have Nasima Ahmed Khan. I also want to extend my special thanks to Shahid Sahab from CSC. He is AP Assistant Professor in CSC department. He has extended his great help in setting up for helping us this fantastic Zoom platform for us. So we are very much thankful to Shahid Sahab, and then we are again very much thankful to Wasim Akram Sahab, who has made this particular event very popular by covering this particular event in newspapers. So these were few names which I wanted to name officially, because they are the real pillars and they are the ones who are behind the success of this national conference, Rtreaet. So this is all from my side, and I'm very much thankful to Director Sahab again for forgetting his name, Khwaja Mohammad Rafi sir. So last words from you, Director sir.
Okay. Thanks once again, Dr. Shaheen. Please close. Very much.
Thank you, sir. Please join us in conference room, sir.
I'm coming. Wish you all the very best. Thank you very much.
Thank you, sir. यार सर का नाम फिर से उल्टा हो गया। इतने सारे नाम पढ़ने हो ना।